So we'll move on to example 2. Here we're analyzing the graph of this function f, and we're trying to find all of its inflection points and the intervals on which the function is concave up or concave down. So let's first just decide when this is going to be concave up or concave down. Whoops. So we're going to have concave up behavior, or in other words, f double prime will be positive. It looks like on this region. So here we have that upward bowl. So that will be our upward concavity. And that happens on the interval from 0 to infinity in the domain. So remember, we're talking about the x values where this happens. So that's from 0 to infinity. And then similarly, if we wanted f double prime to be negative, we're looking at the concave down portion. That would be over here. And that would be on the interval from negative infinity to 0. And then lastly, if we wanted to find the inflection points, it looks like there's just a single inflection point here. We go from being concave down to concave up, and that happens again at 0. So there's an inflection point at 0. Okay, now we'll do the same thing in problem 3. In problem 3, there is a slight complication, which is that the graph that we're given is the graph of f prime. So we're still trying to talk about the original function f. When is f concave up or concave down? Now notice that f will be concave up if f double prime is positive. So let's try to figure out when f double prime is positive. So notice that because the graph that we're given is the graph of f prime, f double prime will be the slopes in this graph. So if we wanted f double prime here, it would be the slope of this tangent line. But notice that all of these tangent lines are positively sloped. So this f double prime is positive, this f double prime is positive. The only place where arguably f double prime is not positive would be here at the origin. That might be a critical point for f prime. So here f double prime might be 0. But I would accept either the answer that f double prime is positive on this region in the domain, so everywhere except for 0, or I would be okay with just saying that it's concave up everywhere. Because the only exception is at this origin point, you might have a slope of 0. It's a little bit hard to tell from the graph, especially now that I've doodled all over it. So that tells us where the graph is concave up, but notice that there's nowhere that the graph of f would be concave down because we've already exhausted everywhere. It looks like the second derivative will be positive everywhere or nearly everywhere, and therefore the second derivative is never going to be negative. So I would just say that f is concave up everywhere. And in particular, there aren't any inflection points because f never changes concavity. It goes from concave up to concave up again, so it's never going to change from up to down or down to up. So you could say no inflection points. Okay, so next we'll look at example 4. Again, we're given the graph of f prime, and we want to know when the original graph of f is concave down. So notice that f is concave down is the same thing as f double prime being negative. So we want to look at this graph of f prime and decide when f double prime would be negative. Now if this is a graph of f prime, and we want to talk about f double prime, then we're talking about the slopes on this graph, because f double prime gives us the slopes for f prime. So we're just trying to find the place where the slopes in this graph are negative. And it looks to me like the only place where this happens is from here to here. So in other words, between an x value of 0 and an x value of 1. So because f double prime is negative on the interval from 0 to 1, that means that f of x is concave down only on this interval from 0 to 1. So that tells us the interval on which that f function, the original f function, is concave down. So next we'll talk a little bit more about inflection points. I think what I'd like to do is I will defer this to the next video just to keep everything sort of coherently together. But these inflection points are going to be useful whenever we are looking for these changes in concavity. The inflection points are easily identifiable in the same way that the critical points are easily identifiable. Here you're just looking for the places where f double prime is equal to 0, and here you would be looking for the places where f prime is equal to 0. So if you need to identify critical points or inflection points, you can start by just looking for places where the derivative can be set equal to 0 or the second derivative can be set equal to 0. But we'll talk about that more in a second.